Hi there, my name is Shai Gelman, and today, since I've done my two presentations on machine learning and the R language, I'm actually going to show you how to run a basic random forest machine learning model in R using Rstudio. So today we're going to be working with a very famous practice data set that's often used to show different models, and that's called the iris dataset. So first, we're gonna library the datasets package. Doesn't show anything because I already libraried it before I started the video, but in general, it would show you that you've libraried the dataset. Then we load the data using this function called data of iris, and here we have a data frame called iris with 150 observations of 5 variables. And here we can get the summary of each variable. Here we see that there are 4 variables split into 3 overall categories. The categories are going to be basically a categorical y variable that we're going to try to predict. And we're going to try to predict the species using sepal length, sepal width, petal length, and petal width. And this is just a summary of each variable and then the 3 species that are found in the data set. And here we actually have the full data set. If you wanted to scan it, you could even sort by petal length if you'd like to, sort by species, so on and so forth, or just sort by row number. That's going to be our default. Now we move on to the second step, and that is going to be splitting our data up into training and testing sets. The training set is going to be used to train our random forest model to come up with our final formula, and the testing set is going to be to check those results afterwards. So first we're going to use the sample function that's available in base R, and what we're using this for is to sample 80% of the iris data points. We're going to be using 80% to train the model and 20% to test the model. And the way we do this is we tell it sample out between the number 1 and the number of rows in iris, sample 80% of the rows of iris. And the replace variable is simply telling R to not select the same number more than once, the same number row. So those numbers that are picked are set in this variable s. So you can see that happen right now. We see that it's just a collection of random numbers between 1 and 150. And there's 120 of them. Then we splice the dataset iris. We tell it, so in R, data frames are always spliced by row, comma, column. Since we want every single column, we leave the column section empty, and we tell it to only provide the rows that are in the vector S. And then for the testing set, we actually use another cool feature of R, which is you can splice using tell R to take all the rows that are not in a certain vector. And we do that by telling R to get the negative S rows. Negative telling R we want the rows that are not in S. So let's do that. You see the training set has 120 observations, which is 80% of the 150 observations in iris, and the testing set has 30 observations, which is equal to 20%. So now we get to the most important part of random forest modeling, and that is creating the actual model. Before we start, if you have never used the random forest or caret packages in R, you're going to have to run both these commands. Just install packages is just the basic command used to install most packages from the CRAN public repository. And the dependencies variable, we set it to true so that all dependencies are installed with the package. And that is important since certain functions inside the package may require other packages in order for them to run. And those won't be necessarily installed if the dependencies value is false, as it is by default. After that, we're going to go ahead and library those two packages, random forest and carrot. The common method that is used to library is to library everything at the top so that the user of the script knows immediately which packages he needs to install, which are going to be used in the script, and then all coding is done beneath the librarying. So here we have random forest and carrot. Since I've already libraried them before this recording, I'm not going to library them again. Next, there are three important statements here. So first, we have the actual training of the random forest. So first we have, so the first variable we have here, this may seem like three separate parameters, but this is actually just one parameter, and it's a formula parameter. This is something special to R, and it basically tells the random forest function how to train the model. So here on the left side, we have the y variable. That can only be one variable. And then on the right side, we have a dot letting the Rstudio know that every single other variable is going to be used in the random forest model. In other situations, we can list, if we don't want to use every single variable, we can list the names of the variables we want to use separated by addition signs, and that lets it know which variables to use in the model in order for the training. And then for the data that we're going to be using to train the model, we have the training set as stated before. So let's run this. Now we have created what is called a forest object. We're not going to go too deep into the forest object, but we can see here certain things that it contains. So first, it contains the call. It contains which type of model. Right now, since our y is a categorical, or as R likes to call it, a factor variable, it's going to be a classification. Other times, you want to predict a continuous variable, and in those cases, we will be using a regression model. Here we have the three factors that we're going to be predicting, so that is just going to be the three species. It's Setosa, versicolor, and virginica. Here we have several things that we don't need to go into since it's going to be a little complicated. We also did not do any hyperparameter tuning, so there's just the default hyperparameters such as entry, which is the number of trees the random forest decides to run, and mtry, which is the number of variables tried per tree. If you want to learn more about that, I recommend studying the theory behind random forests. So now that we saw a little bit about our forest, we can now see how do we use this forest model to predict further. And for that, we're going to be using what's called a generic function that's called predict. And the reason it is generic is because it works for many different object models. So this is, if you understand object-oriented programming, basically every single object that uses the interface of a model is going to be able to use the predict function. So in this case, we use a random forest object to predict the values for the testing set. So let's do that. So now we have predictions, and predictions is just going to be, let me print it out for you. Predictions is just a vector, as we see here, that has the row number paired with the predicted species of that specific row for each row in the testing set. And the rows are actually from the original iris set, but they're only the ones that are in the testing set. Now, the reason we libraried caret is to use a very useful function in caret called confusion matrix. And the purpose of the confusion matrix is so that we can get some summary information about how our model performed on the testing set. So let's run that right now. You can save the confusion matrix value into a variable, but we're not going to do that. We're instead just going to print it directly onto the command line. And as you see, it shows here the predictions. So the value on the y value is going to be the prediction, and the x value here is going to be the actual value. So we see 9 of them were setosa, predicted setosa. 6 of them were versicolor and predicted versicolor. Here we have a virginica that was predicted as versicolor and a versicolor that was predicted as virginica. There's kind of nice symmetry in this confusion matrix, but usually that will not be the case. And then here we have the 13 correctly predicted virginica organisms. Here we have certain summary values. So we have the accuracy, which is 93%. It's pretty good. The 95% confidence interval. So since our sample size was only 30 in the testing set, we can't be sure what the true accuracy would be if performed over a larger sample size. But we see that we have between 78% and 99% true accuracy as a 95% confidence interval. The no information rate is interesting. It shows you what sort of accuracy you would expect if you simply predicted one species without any sort of information. And that's basically just letting you know, it's giving you a baseline for how good the model will be if no training was done. And so in this case, about 47% of the model, or of the testing set values, were of one of the 3 species. And so if you just guess that species for each value, each set of values, then you would have a 47% accuracy by default. So the p-value here is the p-value of accuracy being greater than the no information rate, and here we see that it's very, very close to 0, since if the no information rate is 47% and our accuracy is 93%, even with a small sample size of 30, we can definitely conclude that our model performs better than the no information rate. Kappa is the accuracy adjusted for the no information rate. And here we have the sensitivity and specificity values for each specific species, of the positive predicted value, the prevalence, and detection rate, all things where we don't want to get too into the weeds, since this is not a stats lesson, but more of how to run a random forest model in Rstudio, but thought you might want to see it. So I just wanted to quickly show you an example of our documentation, how you can learn more about any of the functions or packages that I showed you during this video. So here you have a random forest page, and it shows you the formula and all the different arguments you can pass to it, and hopefully on your own you can learn more about random forest models and machine learning in general. So thank you so much for watching. My name is Shai Gelman, and this was my video about creating random forest models in R.